All right, in these two examples, we're going to be finding directions are find the area of the region bounded by the graphs. So I don't know. I need to know what they look like. That's my I don't know. Because I need to know what they look like so I can figure out what my bounds are. So on this last one, we had to figure out the quadratic. We had to figure out which equation was on the top, which equation was on the bottom, where do they intersect? So then I can set all this stuff up. So we're gonna do the same thing here with an exponential and a linear. So the first thing we're going to do is let's create a graph. And so we have an exponential. So if I'm graphing an exponential, every exponential kind of starts at a 0, 1, unless we have an initial value on this. And then as I plug in 1, I would have 2 to the first, which is 2, 2 to the second, which is 4. And hopefully that's enough points to kind of give me a little bit of accuracy, but something that hopefully these graphs intersect each other at one of those 3 points. If not, then I'm going to have to do this math where I set them equal to each other and a log and a linear, or I'd have to use logs, but I have a linear and exponential, might get a little messy. So let's see what we got on this one. So we have a linear equation with a y-intercept at 3 and a slope of -1. So we'd be going down 1 over 1. Perfect. And then down 1 over 1. Nice. So there's that graph. Now the directions don't really say it here, but we're trying to find the area under the curve. And so we're going to, on this particular one, we're going to find, because you could find this area or we could find this area. So the directions we need to specify a little bit more specifically, but we're going to find this area in this example. All right. So that is us doing the area between 0 and 1. And our top equation is the linear. And we will be subtracting the exponential because it's on the bottom. We're going to do the top minus the bottom. So we're going to be minus and subtracting the bottom, which is this. So that is our function that we're about to do. Okay, so that's the top equation minus the bottom equation, like that. So nothing really to clean up. So we just have a 3 minus an x. So the antiderivative of 3 is a 3x minus x would be x squared over 2. The tricky one is going to be this one, that if I do the antiderivative of that, is going to be 1 over the natural log of 2 times 2 to the x. Because if you do the derivative of the natural log, since it's not an e, you would have you do the derivative of 2x. So let's just kind of, if you do the derivative of 2x, it is itself times 1 over the natural log of the base times the derivative of the exponent, which is just going to be a 1. Nope, sorry. It's not divided by, times the natural log of 2 times the derivative of the exponent. So we need to undo that piece when we're doing the antiderivative, because if we do the derivative, we would have this piece. So then we need to divide it to undo it. All right, so, and then we're going to go from 0 to 1. So we'll plug in. So we'll do 3 times 1 plus 1 squared over 2. And then minus 2 to the power of 1. So 2 over the natural log of 2. That's our first one. And then minus, we're going to plug in 0 on this. So we're going to have a 3 times 0 minus a 0 over 2. And then minus 2 to the 0 power, which is 1, minus a 1 over the natural log of 2. All right, so let's see what we get here. So we have a 3 plus a half. That's not a plus. Sorry, I missed the sign on that one. That one's a minus. So minus 1/2 minus 2 natural log of 2 minus 0 minus a 0 minus a negative natural log, so that ends up being plus 1 over the natural log of 2. So if I put this stuff together, these are actually have the common denominator, so I can put them together. We have a 3 minus 1/2 is 2 1/2. We have a negative 2 natural log plus a 1 natural log, so we would get a negative 1 natural log. We got a common denominator, so we could just add our numerators together. So a negative 2 plus a 1 gives us a negative 1. And that would be that area of that little section between the y-axis and kind of that point where they intersect. All right, and then we'll do one more. So we have a cubic and a linear. So here's the problem with this one, is that when we graph this, if you graph that x to the third, it has a y-intercept at 0, and if you go out 1 and cube it, you're at 1. If you go left 1, negative 1 and cube it, you're at negative 1. And the graph looks like that. But then the linear, zoom this in a little bit. The linear is linear looks like this. The cubic looks like this. So the problem with that is, it's not going to be a huge problem, but the problem with it is we have this section where the cubic is on top and the linear is on the bottom, and then this section where the linear is on top and the cubic's on the bottom. So we're going to need to figure out, so we have these sections right here. So from negative 1 to 0, we have the cubic on the top minus the linear. So we'll be doing that antiderivative. And then plus, on this section here, we're going to have the linear. So from 0 to 1, we're going to have the linear minus the cubic. Okay, so kind of two problems in one. Well, let's just kind of go through it. So antiderivative of the cubic is going to be x to the fourth. X to the fourth divided by 4 minus x squared divided by 2 from negative 1 to 0 plus x to the second over 2 minus x to the fourth over 4 from 0 to 1. All right, so if we plug in 0 into this, that's going to be 0. Minus, we're plugging in a negative 1, so negative 1 to the fourth is going to be a 1. So 1/4 minus, plug in a negative 1, so that's going to be a 1/2. So that's that first chunk. Plus, second chunk is going to be us plugging a 1 in, so that's going to be a 1/2 minus a 1/4 minus the 0 plugged in. All right, so that's the area on the section on the left. So that area is going to be 1/4 minus, we'll call that 2/4. So that's going to equal a negative 1/4 minus 2/4 plus we have a 2/4 minus 1/4. So this is going to give us a negative 1/4 plus 1/4, which really is 1/4 plus 1/4, giving us 2/4, simplifying to 1. And because this graph is symmetrical, that area is the same as that area. That area was a fourth, that area was a fourth. So together they combine and make a half. All right, so that was a couple examples, a little bit more challenging, that very much need the visual to figure out which of these functions is on top, which one of these functions is on the bottom. And the visual also helps you to figure out if things start to shift between which one's on the top, which one's on the bottom. we need to break them up into individual pieces so we can do those areas.